numbers. Prime numbers are numbers that can only be divided by themselves and number 1. So, are prime numbers infinite? Euclid asked himself this question many years ago, and that was how he invented this formula. Let's read it and break it down into smaller pieces. First of all, P is what we consider the acronym for prime numbers, and A is what we consider the biggest prime number. So, B is going to be a prime number that is supposed to be bigger than A. So already we see a contradiction. So, B is equal to P1, P2, P3, and many more multiplied between one another. What does this mean? It means that B is formed by the multiplication of all the other prime numbers that we have. So, how can we say that B is a prime number? Here, Euclid brings in the mental formula of Aritmetics, which says that every prime number multiplied by another prime number gives as a result a prime number. So, we could say that the formula could be finished right here, and we would demonstrate that prime numbers are infinite. But we have another problem. If we look at the number b, and we have all of this multiplication, if we divide b by any of the other numbers contained in the formula, we will attain a result that does not have a rest. So, it will then not be a prime number, because as we said earlier, prime numbers can only be divided by themselves and number 1. So, he added the plus 1. If you add the plus 1, you will always have a rest, even if you divide it by any of the other prime numbers in the equation. So, here, he demonstrated that prime numbers are in fact infinite, because you can always have a number bigger than b. So, what did Euclid use to give us this demonstration? He used one of the most powerful tools that we have in demonstration to this day. It is called reduction to absurd. What does reduction to absurd mean? Reduction to absurd is a technique that we use in which we have 3 fundamental steps. Number 1, we must pick a thesis and call it certain, which means we must say that this first thesis is true. Secondly, through calculations, demonstrations, theorems, and many more things, we must declare it false, so we must deny the first option. Lastly, we will find a conclusion. In our conclusion, we can say that the first thesis we considered true was false. So, the correct thesis is the opposite of the thesis we considered true. So, this is exactly what our friend Euclid did. So, he considered the prime numbers not infinite and proved that they were infinite by proving the first thesis wrong. So, what is this principle based on? The principle of reduction to absurd is based on one simple rule, the rule of the third person. So, the rule of the third person, or the theory of the third person, means that given had one information, it can either be true or false. There are no in-between measures. So, it means that if I say that this shirt is red, it can either be true or false, which in this case is true. This principle doesn't always work. There are some cases in which you cannot apply it. Many cases is the paradox of the liar, in which Epimenid, which is a critique man, affirms that critique men are liars. So, in terms of the third principle, we would have 2 options. A, what he's saying is truthful. B, what he's saying is false. So, if we consider the first option, so we think that he is truthful, then he will be saying the truth. So it will be then true that critiques are liars. And it will be then false what he had said, so it wouldn't work. Our second option is that he's saying the false. So if he's lying about critiques lying, then he must be telling the truth. Because if he lies about critiques lying, it means that critiques tell the truth. So there is no way of getting out of it. That is why this principle is not applicable to all the cases, but it is useful in many other situations. Let's rewind and summarize it together. So, first of all, we talked about Euclid's formula to prime numbers infinity. Then we talked about how he got to it, so reduction to absurd. Then we talked about what reduction to absurd is based on, so we talked about the third principle. Lastly, we talked about the paradox of the liar, which reconfirms that the third principle isn't always valid, but it can be very useful.